In this video, I want to show you a variation on the theme of anatomical tribospheny using a specimen called Potamogale velox. It's a African otter shrew. It's a tenrec related to other species that are mostly on the island of Madagascar, but this happens to be a continental African specimen. And what you're looking at here, as I'm sure you recognize, is a hemisected skull, and in particular the dentition. And just like you saw in the domestic dog in Canis, this exhibits some degree of anatomical tribospheny because what you're looking at here is the first lower molar, followed by the second and the still erupting third lower molar. You can see the third upper molar, second upper molar, first upper molar. This cusp here, that's the protocone, and it's occluding into a very small teardrop-shaped talonid basin. Yeah, so I'll just zoom out a little bit, flip the specimen around and show you the same thing. All these little dots are just crud that showed up on the CT scan, which you could ignore, I hope. Anyways, here again is that that first upper molar. The third one is still in its crypt over here, and I'm just going to zoom in on this side, and I don't know if I'm just going to go back to the other side. That's the protocone of the first upper molar. This is the paracone of the first upper molar. And what you see here is the paracone is occluding in a structure that really is a structure this time, unlike in the domestic dog. That's the ectoflexid. It sort of makes a secondary talonid basin. And I'll show you another specimen in a moment relevant to this point. But anyways, that's the paracone occluding into the ectoflexid in Potamogale. I'll just switch over to the other side again, showing you the protocone occluding in the talonid basin. So this is an anatomically tribosphenic crown mammal, but it shows this condition in which the paracone ectoflexid relationship is much more developed, and that's a condition we call Zalambdodonty. So I'll show you another tenrec specimen that shows that relationship a bit more clearly in a moment. This is another specimen of a tenrec, and this one really is from Madagascar. It's Microgale mergulus. Usually in the literature it's referred to as under a different genus name, Limnogale, but it's actually within the radiation of microgales on Madagascar. In any event, this shows you true anatomical Zalambdodonty, and what you're looking at is the maxilla on the top, the lower jaw on the bottom, and the lower molars, of course, are connected to the lower jaw. There you have the lower three molars, fourth premolar. The third lower premolar is somehow damaged in this specimen, so it's just the very tip of the talonid that's present there, and then of course the other antimolar teeth. And the particular relationship I want to point out here is that this main cusp of, that's the fourth premolar, and of the three molars, that's the paracone. And when you flip this specimen around to the other side, the protocone is this teeny little vestige here on this lingual cingulum, and it's really just the main occlusion is really just between the paracone of each of these upper teeth and the ectoflexid of the lower, which itself is not terribly well developed. It's really just this lateral margin of a very small talonid heel. But because the main occlusal part of each of these upper cheek teeth, it looks like an inverted Greek lambda, right? Basically a V shape. And the etymology of the word Zalambdodont it's Greek. Z means very, lambda refers to this sort of V shape. So all it means is very lambda tooth. But it consists of the paracone at the apex, not the protocone. And many paleontologists and mammalogists for decades, up until the mid to late 20th century, thought it might be the protocone, but it's not. And one of the reasons you can tell is this consistent occlusal relationship that it has with the lowers. So the paracone occludes into the ectoflexid of the lower, and similarly what's left of the protocone doesn't really have much of a relationship at all occlusally, but in the Potamogale specimen I showed you a moment ago, it does, and you can see both of those occlusal relationships still in that specimen. So I hope this helps to convey to you what anatomical Zalambdodonty means and how that condition is related to anatomical tribospheny.